now I would like to introduce him to you with a short abstract. The 3D experience platform empowers OEMs to move from legacy tools to an AI-driven, model-based approach. The Gen 7 AI-powered virtual twin experience connects domains, speeds development, cuts errors, and ensures compliance. So step into the future where innovation drives execution. Please welcome the Director T&M at Dassault, Dr. Bassem Hassan.
Ladies and gentlemen, good morning. Good morning. Yeah. So, very happy and very honored to be here with you at HANNOVER MESSE in the stage of digital transformation. I ask you to give me your attention in the next hour. I know I'm standing between you and the lunch break, so I will try to do my best to be entertaining hour. And a small gift for the ones of you who stayed till the end. We will announce at the last slide a very important and very interesting cooperation with one of the biggest tech companies on the planet. My name is Bassem Hassan. I'm the Transportation and Mobility Industry Director at Dassault Systems in Central Europe. But I promise you it will not be about automotive. I will give you some examples from aviation and some examples from satellites. So the title called Future in Motion, shift from legacy tools, which we have nowadays in all of our companies, to AI-powered virtual twin experience. But let me introduce ourselves, who we are. Who from you know Dassault Systems? Please raise your hand. Okay. And who from you know CATIA? Okay, much more. That's why, let me introduce ourselves as a company. Dassault Systems is the second biggest European software company and seventh worldwide. We are a purpose-driven company with round about 25,000 employees with a long-term driven. We have more than 14,000 value-added resellers, CSNI partner, consultants, and system integrators, and we have 35,000 customers worldwide as a companies. But we have a very wide user base, round about 45 million. The slide is 2 days old. I think now it's 46 million users. It's increasing rapidly every day. So where we are everywhere. We have 3 main headquarters for EMEA in Paris, for Americas in Boston, and for Asia Pacific in Shanghai. But we have 194 offices overall, and here in Germany, several offices with a headquarter in Stuttgart, and 76 R&D labs. What's our belief? We have the profound belief that the virtual world extends and improve the real world. And we have a compass. Every one of us in a journey need a compass, and we have a compass. Now our compass is a 3D experience platform with the north show us the social and collaboration within the company and between companies with each others. We have also the 3D modeling. In the south is the simulation, virtual and reality, how to combine both together with all of the data. And last but not least is about information and intelligence. Combine all of these parts together in one unified platform. This platform is powered with several apps, several brands, and serve 12 industries. That said, transportation mobility is one of our biggest industry, but we are there also in aerospace and defense, marine and offshore, industrial equipment, and so on and so on. And we deliver you with a universe of experience, with a consistent software as a service operator, it is our outscale, this is our own brand, to deliver you with a cloud solution as a single operator. Our software as a service approach combine all apps and all solution with one unified platform, which is a 3D experience platform. We have a very well-organized portfolio for each industry, called it Industrial Solution Experience. We are delivering a best practice out-of-the-box processes, runnable and executable workflow defined by processes. And under this process, you will find different business rules, tool rules, and apps like a smartphone. And last but not least, we deliver you an experience as a service. We can also deliver an added value immediately for your company. So, till now, you know who is Dassault Systèmes and how big is the company, but let's pick up one industrial example, which is transportation mobility, automotive industry. Let me run a video about a near future mobility and which challenges we are facing in automotive industry.
Distances and bringing people together. But what is mobility of the future? Can a car be much more than just a car? Imagine a future where the car is a meta object. An object offering far more than just transportation alone. Imagine an embedded experience, personalized to each individual end user. A universe that extends the very concept of mobility services by continuously connecting service and system providers to bring the most memorable moments possible to their customers, while at the same time ensuring a safer driving environment by actively tracking and preventing accidents, and maintaining smooth traffic flow. This is the future of connected mobility, empowered by Dassault Systèmes 3D Experience platform. By providing deep insight into how brands move people and enrich mobility experiences from the outset, the platform enables commercial innovators to design, test, and run physical and virtual value streams in a single connected ecosystem, achieving mind share and creating exceptional experiences. Welcome to the future of connected mobility.
And however, the car driving autonomously, it was a non-alcoholic wine, okay? So, very nice to have autonomous driving cars, will help us a lot. It's also very important to have a lot of advanced driver system in the car. The car is connected to the environment, to the ecosystems, but such scenarios bring huge challenges for car OEMs with it, also for the suppliers. Which challenges we are facing now? We have increasing new customer experience. We know it from our smartphones, mobiles. We are getting updates, and from before the update to after the update, we have an AI assistant on our mobile phone. New customer experience come every day. And the expectation from the drivers also will be the same for the cars, to have new experience, to have new functionality over their updates. The second challenge is about electrical connected and autonomous vehicle. In order to deliver a safe autonomous driving functionalities, it's not an easy approach. It's very, very difficult and very complicated processes. And we face monthly new regulation came out, like UNECE, I will show it later, and this compliance regulation go in deep of the development process, methods and tools, which is used. We have also to face the quality issues and to be very fast and to reduce the cost. which is called China speed. We have to be very fast to have to deliver new models continuously. Also, how to organize my manufacturing sites in a flexible way to have mass production to mass customization. And last but not least, it's all about sustainability. It's all about our CO2 footprint, how to bring it in a nice way and under control. That means with this huge amount of new customer functions in the car, which are distributed all over the car systems, we have a very rapid increasing in complexity of the product itself. The complexity reduced in an exponential way. At the same time, our process, methods, and tools, which came originally from mechanical development, are increasing in a linear way. And that's why we have a gap in the automotive industry. Plus, the complexity of the product is that the complexity was the regulation pushed on. Every one of you is involving of software development in a car and OEMs can know that a huge amount of regulation came every month. Sometimes it's about ASPICE, automotive SPICE, maturity level of process methods. Sometimes it's about functional safety, ISO 26262 for functional critical systems in the car. It's about UNHCE for over-the-air update or UNHCE regarding cybersecurities. It's about SOTIF and. There's a huge amount of compliance. That means every engineer in the car OEMs who are involved to develop a system or a part of the system, is that software, hardware, or electronic, has to apply 1,000 pages of compliance and processes, read them, and try to transfer it in his daily work. That means we have a very increasing complexity in the product itself, and the regulation and the compliance processes pushing also in a complexity. And we can see this gap between this complexity and our tools, process methods and tools nowadays. V model is very well known in the automotive industry, and we can see the problem arrays in the right-hand side of the V model. We have a very high coordination effort during we are integrating the different system of the car and different software and different functions of the car, which is called Big Bang integration. Okay, we are defining something, go to do our homework for 5 years, and we will meet each other in the car and make a Big Bang integration. That's why we have a very huge high coordination effort on the right-hand side of the V, late and costly changes, also change in the requirements. However, this requirement should be defined on the left-hand side. We have also a change in requirements on the right-hand side of the V, long development times. We are not yet on the China speed regarding automotive industry. And we have a lot of product quality and recalls nowadays. But the cause of this problem, which happened during the integration, is the left-hand side of the V. Why? Because at the end of the day, if we like or not like, a car is a mechatronic systems. A car is described during 3 main disciplines. It's a software, it's a hardware, it's electronic. To master one of them, it will not be enough. We need a uniform understanding of the whole system. We have nowadays a component-oriented. Everyone develop his component away from the other department, silo thinking, silo development. We have huge amount of models, which are discipline specific. We will find a huge amount of MATLAB Simulink models, which is describing control or algorithms. We will find huge amount of UML, which describes the architecture of the software. We have huge amount of 3D, CAD, CAE, and so on. But we have a very limited discipline or cross-discipline model which describes the whole system to break down the elephant car or mobility solutions down to systems and subsystems, and then start to build the discipline-specific solutions. Transparency on traceability. If I told you how the traceability is doing now in the automotive industry, it will be done in a very manual way, which is not able to deliver the right transparency. And we separate the engineering from production, which is very wrong, and we will show it later how to integrate them together. In a very simple way, what I want to say is, do we have models which describes or break down the system specification, car as a system, to the subsystems, and from there to go through the different discipline, mechanics, electronics, control, and software engineering. And this is a system model, and this is our DNA at Dassault Systems. The DNA of the 3D Experience platform is a systems engineering approach based on compliance, based on ISO 15288 systems engineering approach, and supported by very well-defined model-based systems engineering approach. And to be honest, if you are searching for an example for a company who developed without model-based system engineering and system engineering and with, you will find very few examples. And one of them is from Tesla. Tesla tried to optimize the range of the e-car on a component level for 5 years. And they considered each component alone. And they get 15 to 25% improvement in the range. After 5 years, they changed their mind and said, okay, I will consider the whole car as a systems and the system of eDrive itself, and I will optimize the whole system and its interfaces, and they get 40% optimization. It's a very clear example and call to consider the whole product as a systems and break it down, and not only to think on silos and think on software separated from hardware and electronic. Architecture, every one of you have massive number of architecture in your company, but what about the architecture we are talking about? It's about architecture-driven development, which describe a functional and logical architecture and drive from them a software architecture, mechanical architecture, or electronic architecture. Very nice to have challenges, but how can we help? And now I want to tell you that Dassault Systems deliver solution since 1981. With the first computer-aided design to have a 3D representation of a part. Then in 1989, we delivered the whole mock-up of a product. The first one was an airplane, and then moved to 94, product data management. 99 was product lifecycle management. Then in 2012, we connected all of dots of PLM, BDM, 3D representation, put a systems engineering approach on that, and we delivered 3D Experience platform to cover the whole lifecycle management of a product from start to the end. Then in 2022, it was a pandemic, and we get involved a lot with the development of COVID vaccination. Most of the COVID vaccination trials are done with our 3D Experience platform with Medidata, and we have also a virtual twin of the human. And in February this year, we announced a 3D universes, which combined virtual and reality with help of AI. If I look to the automotive industry, of our OEMs or suppliers, each company has its own digital mockup, its own BDM, and its own PLM, product lifecycle management. They are in file-based in the most of the cases, and everyone are talking about AI and how to use an AI nowadays. I have here an announcement for you. We can jump from file-based to AI approach directly. We will show today an AI which is available in our portfolio, and our advice to all of you, make a step in between. You can't jump directly from file-based to AI. Why? And it's very important to understand why. All of us are using ChatGPT, for example. ChatGPT learned from huge amount of data and text and boxes which found on the internet. Imagine you gave ChatGPT not a POC, but individual pages to learn from it. Or maybe a little bit different or a little bit more difficult for ChatGPT to give them individual words or individual letters. The ChatGPT model will not be able to learn from individual pages. He has to get a POC which tell a story from the start to the end, to learn the grammatic, to learn the approaches inside it. It's exactly like the AI model in engineering and manufacturing of OEMs. We have massive amount of data assets. We have huge amount of tools which are used in engineering and manufacturing. And we have also connected customers and products information. We have to bring them together and infer this information to put in a semantic in order to give it to our AI model to learn from it. That is a specification document, that is a representation of port, that is a representation of software. That means we have to do the step to put these puzzle pieces together in a semantic to give it to the AI model as a whole book in order to learn and understand how your intellectual property are working inside the company. You can see here, it's on your intellectual property. And then the AI model will be able to predict and generate for you engineering items and products. But how we can break the silos, how can we connect the dots? We are talking about thousands of tools and VBAs and Excels and PDFs in the development and also thousands of tools in the productions. How we can connect the dots? Is there a referential or best practice which we can deliver? And the answer is yes. We can deliver a referential and best practice. And we tried it also with a lot of OEMs, and it was very successful. We advise you to cover the whole life cycle of a product development, starting with an enterprise strategy and portfolio, go through the ideation and exploration phase, during the development itself, the whole V cycle of the development, go to the production, usage after sales, and last but not least, reuse and disposable. Break the system in its own subsystems, break the subsystems in the discipline like software, hardware, electronic, integrate it together and go. We also combined the waterfalls, these phases and milestones, what you see in the upper side, with an agile approach, which is now standard in the software and electronic development, with sprints, with PI planning, program increments planning, and so on. That means we combine the whole project management approach, classical one, waterfall one, with the new agile one. It's the same approach. And if you can see here, our 3D experience is not a monolithic. We shouldn't replace all the tools you have. It's about an enterprise governance platform to do cross-management processes like portfolio management, like project management, agile collaboration inside the company, but also between your company and your suppliers. It's about configuration management, which is very important for us. It's about maturity management, release management, quality. Very important is traceability. I'll show you one example how you can trace a member of the board decision down to a C code line. Full traceability, and in order to get the impact analysis, in order to analyze any changes or in order to analyze any errors and defects. Sustainability as a topic, CO2 during the whole cycle, and last but not least, change management. So if we can imagine, we are now in a very complex landscape in one city, and this city is our development city. And we have to move from A to B, from the engineering to production, or from production back to engineering, or from software to hardware. In a city, we will use metro lines or subways. And we try to simplify this, connected the dot with 4 out-of-the-box solution with these metro lines. The first one is the blue line. The blue line is there in order to have a management. It's about systems engineering governance, where I'm existing now in my project, which projects are running, which maturity level did I are achieved in my project and so on. The second metro line is the yellow one. The yellow metro line is about systems engineering approach and how to break the silos between the different disciplines and break them down and integrate it and make an traceability. Third one, which is our main DNA, modeling and simulation. Do everything for everyone in a virtual way first. Shift lifting to approach a minimum 50% of less prototypes, real prototypes. Make everything in a virtual way. And last but not least, the production. Consider the production hand in hand with the engineering from day one, because in production, deliver for you specifications in each part, how they are manufacturing it later. And if you can see, each bubble of it is a station, and you can drive from one station to the other in a very simple way. And in order to approach your development in an easy way, you can use the 4 metro lines and several stations over the metro lines. It's nice, till now it's a theoretical approach, nice how to use it. I will show you one example. What we presented last year for BMW together with Unity AG, how to give a battery a second chance, a second life after recycling. There is requirement from OEMs that the battery have to be traceable. The battery should have its own life cycle with its own serial number. And this serial number is decoupled from the car VIN number. That means we have a battery built in the car and we have to reuse it later after recycling. For example, in your home to save solar energy. In order to do that, we have to start with a requirement and go through whole life cycle until end of life of a product or end of life of subsystem of this product, which is a battery nowadays. And let me show you it live in 5 minutes. So, starting with a specification document, which maybe came from outside the platform. It could come from requirements engineering tools like CodeBeamer, like everyone is. It's here to show you that we are open for all tools are used during the development cycle. Starting with this requirement, we have a specification document came from outside the platform. However, we have the availability. We are open to import it from the outside the platform. And we can see here, regarding a maintenance, we have a requirement which is told us to have a serial number tracking. We bring this requirement as a model-based systems engineering approach, define them in a use case. This use case is happened during a maintenance or during a de-assembly of the product during the second life. And we describe this use case, how to de-assemble the battery and how to get the serial number and digital passport of this battery during a maintenance use case. Describe it in a functional, we have also an early BOM, early bill of material or a logical description vehicle solution structures. And we can drill down from vehicle level to e-drive systems, from e-drive system to the battery as a systems, and we put this requirement in the subsystem battery that should be traceable. And the end of the development, we have a holistic bill of material, an engineering bill of material, and in this engineering bill of material, we will find our battery, and in this battery subsystem, we will find also that has an attribute which is called has a serial number. Let me see impact analysis and traceability during the whole development cycle, starting with this very simple requirement, make the life cycle holistic, go to use cases, from use cases to functional, logical, physical representation until we have our bill of material. That is the engineering part. Moving from engineering BOM to manufacturing BOM, which is now very manual processes. You can see here, we are doing our assembly line planning. and direct coupled our engineering POM with the battery, with the specification of the battery, with the serial number of the battery, put it in an assembly line planning in the next step, and show me where this assembly is done in my assembly line of the battery. And you will see here, it show me directly that the attribute has a serial number, is pushed to the manufacturing POM, and it's a characteristic here in the battery assemble station during my assembly line. Go to operation, okay, I did the design, and now we are producing cars every 5 minutes. There is a car go through these stations, and in this station I will have as to scan with a very simple work instruction, have to scan the battery serial number with my barcode scanner or any other methods, and to save this information, the serial number of the battery, to a specific car with a specific VIN number during the manufacturing. So now I have a wide data set of VIN numbers, and this VIN numbers has a huge data set of serial numbers of components under them, or the battery itself, and I can retrieve the information everywhere and each time, from VIN number to components and parts and serial number of the battery. But not only, after the car is on the street and communicated with the cloud, they are pushing information to the cloud, and I know, so for example, I can use a data lake, external data lakes, not our data lake. You can use any external data lake to retrieve information. Which car, with which VIN number, are driving in which country, and which serial numbers of the battery are there, and also retrieve some fault and defects. I know now there are 56 defects from this car types, from this configuration with a battery, and I can push this information back to the engineering and say, okay, this type of battery are doing a lot of the problem, and maybe you can make a predictive maintenance, or you can make a predictive logistic to push 30 battery packs to Japan, because 30 cars there will join the workshops in the next weeks. We are accelerating the product cycle. We have our future product development cycle. By using architecture-driven and not bill of material-driven approach, we will save up to 60% of errors with shaft lifting. By using a validation for modeling and simulation in CAD and CE in combined way, we are 3 times faster. The collaboration between OEMs and suppliers, which had take weeks in the past during export, import, re-export, and re-import cycle, it will be an integrative approach, will be from weeks to days. No one should read the 1,000 pages of compliance, because everything you see, there is a compliant by design, which means with this approach you are compliant against all the compliance regulation, what we showed in the first. We have here 95% sparing of manual synchronization between engineering POM and manufacturing POM. And last but not least, we can save 80% of the manual effort preparing change orchestration, like change order, change request, change order, and change actions. That's why we will approach with that a future PIP, which is much more faster than our current product development cycle. Who use it? It is proven already that something like that will bring such much amount of sparing in cost, in time, and in collaboration. Yes, 72% of the cars in 2021 on the streets was designed with the systems tools. 99% of the top 400 suppliers are using our tools. Top 10 of 10 EV makers are using 3D Experience platform. Tesla, Rivian, Neo, and so on. Not only the top 10, 150 new EV makers are using our tools in daily way. They are in greenfield approach and can use it end to end. It's okay. the newcomers don't have the backpack of legacy systems and legacy information. This is easy to introduce such approaches, not only the newcomers. If we have here a worldwide view about a very established groups of car manufacturing, they are 13. 10 out of 13 used our CATIA in the past. And 10 out of 13 moved from CATIA to the 3D Experience platform exactly for this reason. Break the silos, connect the dots, accelerate the development. And we are very happy about the Lighthouse program renewation, which 2 years after starting to use 3D Experience platform end-to-end, he spared 1 year of the development cycle, which is a huge amount of money. Imagine your car will be 1 year earlier than your competitors and saved with the 3D Experience platform in the first year 200 million euros per year. We are, in the most of the cases, part of a saving program. Introducing 3D Experience platform, yes, it costs something, but it saves a lot of money and a lot of time. And the next year, Renault will save with 3D Experience platform 2 years of the development cycle. Okay, I talked a lot about here our legacy and our connected the dot approach and 3D Experience platform. But I will show you also the AI. We announced on the 1st of February our Gen 7, Generation 7. It's not a version 7, it's not a different version. It's a Generation 7, which is 3D universes related AI-based. So let me show you a short video.
Imagine 2040. A future where the experience economy and the circular economy have converged towards a generative economy inspired by nature and life. A future where universes interact harmoniously, where each element is paired with a virtual twin, enabling continuous dialogue. A future where infinite loops seamlessly connect the virtual and the real, nourished by real-world data.
Since our founding in 1981, we've used our science-driven imagination to advance industry and humanity. As pioneers in virtualization, 3D product lifecycle management, and virtual twin experiences for products, living beings, and organizations, we are consistently at the forefront of innovation. To enable products, living systems, and nature to interact, we create universes that unite virtual twins with objects and users in their contexts.
In medicine, these universes will allow us to better understand the biological processes at the cellular level, to test, personalize, and optimize treatments for more preventive healthcare. These universes will empower industry to leverage human potential in new ways, including inventing resource-efficient products that have the capacity to transform into something new. These universes will enable new infrastructures to meet user needs, while also considering impacts on cities, air quality, natural resources, and energy performance.
In this promising near future, Dassault Systems does more than imagine how to change the game. We're providing virtual twin experiences to key actors who possess the imagination and drive to sustainably transform industry, healthcare, and the world all around us.
It's not 2040. It's now. Welcome to Gen 7. And we still have around about 20 minutes. And in this 20 minutes, I will take you with me in a journey of AI with a live example from customers which are already existing. And I will show you only the available AI assistants in our portfolio today. It's not about the future, it's not in 2040, it's yesterday there. So let me have a short introduction about our 3D universes. For manufacturing industries, for life science and health and infrastructure and city, we have for each industry there in something from a portfolio, and we can show an example from each of this industry. Maybe because I'm come from automotive industry, I'm a child of the automotive industry, I'll show you here a very short video about, okay, how to integrate designs, engineering, also model-based manufacturing, virtual assembly together, all of this cycle with different AI agents. If you have did your homework of learn the model will take over a lot to do with you with different virtual agents. So you can see here, and then from engineering, and then manufacturing, and then the design of manufacturing, and robot programming, and so on, and so on, and so on. Everything is there and can be supported by AI. But we see the 3D universes in 7 main pillars. The first pillar is virtual twin for everything to everyone. Combine the virtual and reality, we can build a virtual representation of everything during the whole life cycle. But not to build the virtual twin itself will bring an outcome, but to put an experience on it, to put a simulation, to put an simulation of everything with an experience, and not to put it by yourself. But the third pillar is to have a generative experience, to have an AI who can help you to generate this experience. We also have which called virtual companion. You can double your capacity or capacity of your employees by put a virtual agents which can copy you or double your work and do different works with different agents. We cover all cycle of the life in a DevOps way. We have also put sense computing, and that's about the announcement, the last slide. Be aware of that sense computing, how can we integrate in a haptic way with the virtual twin itself. And last but not least, our and your huge treasure, it's a knowledge and know-how in your companies. So no other companies or newcomers has such a huge amount of data and your DNA, your know-how, and how can we retract this information and know-how, and how can we push it for your future projects to support and to accelerate to do it. So, which means we are the most trusted company to have your IP generation and your IP management, which is your treasure and which is your DNA. So, how our portfolio looks like regarding AI. You can see here different examples, a huge portfolio which is existing now as an experience as a service. We can provide it to you now. Starting with generative experience engineering or regenerative experience engineering, like generative 3D based on a specification document. You don't have to make a 3D part by yourself, constructions of the 3D part yourself. The AI agent can do it for you. Or generative assembly, go to the sustainable global industry operation like a virtual factory or scheduling intelligence. Go towards experience in life, how to interact with your end users and get also invoices from end users. Research and innovation for sustainability in generative material. The AI agents can help you also to find a new material, find a new combination of the materials, or reasonable and portable business model. Generative requirement. Requirement is a very huge approach which AI can help with, and I will show you an example of that, which was responsible for our requirements engineering. Requirements is hard, and AI can help. Let me keep it for later to show you an example. Or personal assistant for your daily life. Aura is our personal assistant. And. There's a huge amount of examples, and I have only 60 minutes. Let me pick up some of them. Of these examples. Aura, this is our personal assistant. Aura knows everything in your company. know everything in the internet and can help you with an natural language processing. You can ask them about projects in the past, you can ask them about researches, you can ask about everything you need, and they will provide you with answers like ChatGPT. This is not the best one, but we can show more advanced requirements engineering. Every one of you knows that in order to develop a system or a subsystem, you have to write and describe 10,000 of requirements, and they're changing every day. Imagine you are in a satellite company and you are developing a satellite for Europe, France, UK, and United States. And the regulation for this company changing every day. And you have here an AI agent search for you in internet, the compliance, gets the PDFs, which has the main requirement translated in requirement items, but also has a traceability between your requirements. I'm back to the PDF and regulations, and translates this requirement in executable formulas in order to be sure before start to develop that requirement not in conflict with each other, and this requirement can be executable also. You can see here my AI agent extract requirement from PDF, put it in a requirement document. From requirement document, they got it in executable formulas. They simulated it, find out which conflict there are or gaps in the requirement, and automatically generated test cases later in order to test each requirement. You can see here the whole cycle with different AI agents. Or regarding program risk intelligence. Imagine you are a program manager for a huge projects, millions and thousands of tasks. How can AI agents help you as a program manager for that?
L&T is manufacturing energy plants. Each plant is between $1 to $1.5 billion capital investment and shall be delivered within 18 months and represents around 300,000 tasks. This is a holistic program management challenge to continuously synchronize asynchronous disconnected processes such as engineering, construction, and procurement, as well as learn and extrapolate from them. In this journey, virtual world is essential to interpret what's happening in the real world. The real world is characterized with massive flows of event data captured on the edges, on the field, through drones and RFIDs, along with millions of transactions in ERP. Whether you are CEO or construction manager on the field with your mobile device, the virtual twin is the single place to reveal the holistic truth. From monitoring weak signals on essential KPIs down to tracking specific activities on an isolated piece of equipment. In one click, we drill down to the single component out of 1 million in this plant that have not yet been ordered and access to all relevant information and documents. Of course, not only knowledge can be accessed, but collaborative action can be taken, such as changing priority and resources allocation without using emails or spreadsheets. Virtual twin experience is definitely an elevation and normalized projection of the gigantic program, related knowledge and know-how. Let's start predicting risks and orchestrating the right preventive actions to mitigate challenges before they even occur. At L&T, we have already delivered about 15 programs, $25 billion worth of programs, 3 million tasks. This is our learning set for automatically being capable of identifying all of the risks that may affect a new program. While risks and weak signals are revealed, context, historical learning are accessible to the user so he can interpret, understand, characterize the risk, and of course leverage the best practices and past work from his peers to take most relevant preventive actions. And by the way,
Okay, I will skip the whole video, but I think the idea is clear. Everything, virtual twin of the whole project, risk management, project management, quality, time, cost, everything is there with the help of AI agents and can save a lot of risks. Also, here is an example. I will skip it for procurement in order to get for a very interesting approach. We saw a huge amount of requirements. Who can design in a compliant way against this requirement. And let's see an example from aviation.
All those requirements can be conflicting and difficult to harmonize. Dassault Systèmes' generative design solutions powered by AI is a game changer to tackle this challenge. First, passengers' seating configurations define the possible loads on the structure. Second, the seat designer defines the design space of possibilities by selecting different manufacturing processes and several materials. Then, several design alternatives are generated for trade-off study, thanks to 3DS ModSim solutions combining the power of CATIA modeling with Simulia solving technologies. All generated design complies with the structural requirements. They are made of continuous and accurate geometric representation that can be modified. The seat designer remains in control and selects the best design. At the scale of a complete aircraft, this represents a saving of 976 kilograms only for this structure, and will result to 9.1 kilograms CO2e saved per 100 kilometers.
This is something like that took months in the past. To design something is an according requirement, to test it, to make an virtual, this is nowadays, this is in one click away from you. Also about manufacturing, it's about an NC programming. You don't have to make an NC programming. The systems know your NC machine, know your part, and generate automatically your NC programming. Or generate a planet layout. You can have an point, cloud points of your of your real planet with scanners and cameras, and the virtual agent and AI agent will identify the robot and build it for you in a virtual way. I will skip the two videos, go back shortly. Okay.
To solve a real headache.
I want to give here you two concrete examples. We still have 8 minutes. Two concrete examples how AI can save a lot of cost in automotive regarding to watch the material cost changes in the
to solve a real headache for the car OEMs, which is identify the dependency on volatility of raw material. By consolidating material information from many disconnected sources, it computes for any car configuration the actual decomposition by material and offers a forecast view of the potential impact of the raw material evolution on the price of the car for the next years. In our case here, the impact is about 1,000 euros. On the right, we are creating a new risk with a 250% aluminum price increase. Doing what-if scenario on the risk is as simple as a drag and drop, so here we see that this risk is actually having an impact of 500 euros additional material costs for this configuration. Then we can identify what is the vehicle with the highest risk. It's an electrical car, and it has 3,500 euro price increase. Of course, at any time, we can visualize all of that data in the virtual twin of the car. It is, again, as simple as a drag and drop with a color washing to identify the specific aluminum components. Material cost intelligence can also identify for each car configuration what are the components the most impacted by the increase of raw material. In our case, this is a simple bracket, a cheap part with a price around 3 euros, but a part bought in a large quantity with almost 19,000 units per year. We can then build up a team to solve that problem, create the issue, attach the risk we created and the parts we identified. Then we allocate that issue to the procurement team. The procurement department has access to an advanced dashboard that actually allows to navigate everything that is being purchased. Not only they know the distribution of suppliers, they also know their sustainability index, and they have access to all of their factory location, their ratings, or the benchmark that have been made in the past. Everything that have been procured through that supplier can be seen, even information about the models and the configurations. So let's go on the issue that I've been working with, and as a procurement person, we receive the issue and sees that it concerns a part. The procurement person can drag and drop this part on his dashboard and understand that the part is provided by 2 suppliers. With a new drag and drop, he can immediately identify out of all components of the OEM the ones that could be the reasonable alternatives. He identified that 3 parts having the same 3D shape or function or location, and second one is actually lighter and cheaper, so it's potentially an interesting alternative. The next thing he can do is to verify whether he does have a supplier for this part. Once again, with a simple drag and drop, he can see that there is a supplier named MESSE. Then he can allocate the tasks to an engineer to work on this task and perform.
It's a great example about cost optimization and how to keep your cost under control, however, external factors changing rapidly. The next example will show how important to extract the information from your company, from your intellectual property inside your company, and how our AIs are learning from your patrimony. Patrimony is your data there. As an example from a French OEMs, they have thousands of configuration developed during the last years, and they have DMU, digital mockup of this configuration. What we do is to understand this configuration, to import these configurations, break down the systems of the car and subsystem and assemblies in parts, and understand the relation between the parts and each others, and give it to the AI model to learn from them. The AI model know now your company DNA, know now how you develop the parts and which relation and functions they have between each part, and put it for you for the next project to be and carry over. You understand everything, and he will support you to develop. So I'm on time, and as I promised you, we will announce or re-announce a very interesting cooperation with Apple. Since computing, we started native on Apple Vision Pro. We had a very close cooperation with Apple, which we are very happy about that, to put everything what you see from day one, from a decision of the portfolio till end of the life in an Apple Vision Pro and a virtual life. We will deliver in June 3D Play native app on Apple Vision Pro, and we can see everything in the future, not on a 2D display, but on a 3D live Apple Vision Pro. My last message for you is that time to act is now. Feel free to contact us about our social media or to contact me directly on LinkedIn to answer your question. Thank you very much.